In part 2, we are going to look at this question from a simple direct DC motor. Remember, a motor is the type of device that uses electric current to produce rotational motion. So here, we are going to look at how questions can be asked from this particular area. And we are told, explain why the coil turns continuously when the motor is connected direct to direct current supply. You should refer to the brushes, the split rings, commutators in your answer. So in this, we need to remember that when current flows through a conductor, and especially this coil that we are having here, the current is going to create electric fields around that particular conductor. And when those electric fields interact with the fields of the permanent magnet, then we are going to have a force produced. So we are going to say that we have magnetic fields here. From the permanent magnet, we shall have magnetic field. But at the same time, when current is going to flow through the coil, it's going to create magnetic fields around the conductor. So since we are having two types of fields of the permanent magnet, at the same time fields of the current that is flowing through the conductor, then it means there's now going to be an interaction between the two fields, and then in the process there is a force produced. So the coil is having two sections. There is this part of the coil and there's the other part of the coil. You realize that current is going to flow in opposite direction. In this one, current will flow through the brushes and current will follow that direction. It goes round, then current will be coming this way. So since current is flowing in opposite direction in the coils, the two sides of the coil, it means we are going to have forces which are acting in opposite direction. So one end will experience an upward force and the other end is going to experience a downward force. Now let's see how you are supposed to respond to this. I started by saying when current flows through the coil, it produces magnetic fields. So when current flows through a coil or a conductor, magnetic fields are created around that conductor. These magnetic fields, which are created due to the flow of current, are going to interact with the fields of the permanent magnet, and this interaction is going to result to a rotational force. The brushes maintain the sliding electrical contact with the split rings commutator to allow the coil to spin without the wires tangling, and the split rings reverses the direction of the current after every half turn. Yeah, current reverses after every half turn, and then in the process the coil is going to rotate continuously in one direction. So that is exactly how you are supposed to put your answer whenever you are given a question like that. We have the next part here whereby we are assessing how to determine power. Remember, power is the rate at which energy is transferred. And in that case, we are having two people here, person A and student A and student B, who are doing this experiment. And the method the students decide to do is that student A is going to have a stopwatch and is going to start immediately, tells this person to start running up, and then is going to time how long this student B going to take to run up the steps. Now in the process, they are going also to use the mass of the student and the height over which the student has run. Maybe in the process of finding energy, they are going to find energy that is mgh, which is going to the gravitational potential energy over this height, and then use the time they have recorded at that point to determine the rate at which energy is transferred, which is basically power. Now student A starts timing the stopwatch and shouts go, and the same time student B begins to run up. The student repeats their method for more times. Give a reason why times recorded may not be accurate. we bring an issue of reaction time here. Yeah, after the other person has had, will take time to react and start running. Also, there could be reaction time for student A to start and stop the stopwatch, and then the process, this may be inaccurate. There are 24 steps in total. For each step has a height of 19 centimeters. So which means for us to find the total height, it will be the number of steps times the height of one step, and that is going to translate to 4.56 meters. And this is going to be what? This is going to be the height in meters. Remember, for you to work out energy or gravitational potential energy, you must have your units in SI units. In this case, we have to convert now the distance we have gotten in meters here in centimeters, because 24 times 19 will be in centimeters. Then you have to divide that by 100 so that you can have it basically in meters. So we shall use this into this section here of the formula. GPE is equals to mgh. Of course, we were given the mass of the student who was running up to be 67. So if you work it out, you get 3055 joules. And writing it correct to one significant figure, that is going to translate to 3000 joules as required. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'll be uploading part 3 of this paper, you will be notified. If you have not watched part 1, you can be able to check the link in the description so that you can be able to access part 1. So let's dive in and continue with the next question. Then we are told that the table shows times recorded by student B. Then we are supposed to calculate the mean. Remember, mean, you are going to add all the time divided by the number of times the times were recorded. So if you work it out, you'll get your answer approximately 4.63 seconds. And calculate the mean power. Remember, mean power is going to be energy divided by time. So power is the rate at which energy is transferred. So in the process, you are going to say energy is going to be equals to the power, and the power is going to be energy over time in that case. So we are going to say 3035 divided by 4.63 because time was 4.63. That's going to be 660, and power is in watts. Power is given in watts. So we can be able to proceed to the next part. In part C, we are told the student extends their investigation by calculating power of students, different masses running up the steps. And this is what the data, this is 1, 2, 3, 4, these 4 values that were plotted. Now, no, this was the first one that was done, but they did 3 other students, 3 other students, and they were able to have this conclusion that greater mass of person, the greater the mass of person, the greater the power when the person is running up. But you see, they have just taken just 3 extra. They have just taken 3 extra students in the process of extending the investigation. And we can say that this sample they have taken, just 3 students is not enough to make this particular conclusion. They are supposed to do it with quite a good number, like around 6 data sets, so that they can be able to conclude. And also they need to do more students with mass within or between these ranges they have done here, so that they can be able to see whether the trend is going to be the same. So note this, we can say, and in our comment we're going to say not enough data points. This data is not enough to make a valid conclusion, and they need to test a range number of masses of students in order to make that conclusion. Yeah, so should also test students with mass between the values already they have tested, so that they can be able to check whether this trend is the same. So that's the comments we shall have for this student who did this investigation, and so that we can be able to proceed to the next part. In question number 7, it's about pressure, and we are told about a container of water, and there's a bubble inside water which is going to be acted upon. Pressure is going to act on that bubble. Then which diagram correctly show how the pressure of water acts on the stationary bubble? We need to understand that pressure in liquid depends, of course, in depth, but this one is stationary, so it means that pressure that is acting on a bubble should be constant around this bubble. So meaning that you have to check the answer that has got equal length. Yeah, so this one is not correct because this is shorter, this shorter than the rest. So pressure is equally applied in a liquid according to pressure in fluids. Yeah, so the correct answer is D there. The diagram shows the air bubble rising to the surface. Remember, as this bubble rises, depth keeps on decreasing, and when depth decreases, pressure is going to decrease. In the process, since pressure is going to be less for the bubble, then the size of the bubble is going to increase as it's rising over. So you are supposed to assume temperature was constant and explain why the bubble increases volume as it gets to the surface. We're going to say pressure in liquid decreases with decrease in depth. As the bubble rises, there's less weight around or above it, so the pressure exerted on the bubble is less. And remember, volume is inversely proportional to pressure. If you apply greater pressure, a balloon will become smaller. So that's why at this lower end there is high pressure, so the volume becomes smaller. At this upper end, volume is pressure is less, so there will be larger volume because it will be compressed with a small force. So basically that's what I wanted us to look at, and then we have explained why the balloon does not pop when pushed on a board of nails. Here we are having a set of nails in this balloon below the boards here, many nails together, but when the person compressed, this balloon did not burst. But when he used a single balloon, the balloon was able to burst. And what is the reason behind that? When you have a board of nails, remember, you are going to have a large surface area, and so pressure is going to be spread over a large surface area. Then in the process, pressure is going to be decreasing. Remember, pressure is equals to what? Pressure is equals to force over area. So meaning, if you apply a force over a large area, pressure will be less. Yeah. So in that for that reason, the balloon is not going to burst. When the balloon is pushed onto the board of nails, force is spread over a large area. Since pressure is equals to force over area, the large area results to a smaller pressure. And when small pressure is small, it's not sufficient, it's not enough to burst this particular balloon. But when this person used a single nail, we are going to say that there will be sufficient pressure that is going to burst the balloon. Moving to question number 8, whereby we are told a student uses a ripple tank to investigate water waves. The student was supposed, or we were supposed to describe what we mean by transverse waves. Transverse waves are a type of waves which are characterized by crests and troughs. Transverse waves have crests, have troughs, and we can be able to define a transverse wave as a wave in which particles vibrate perpendicular to the direction of the wave. Particles vibrate up and down. For instance, if we are talking about water waves, if you take a bottle of water and you throw it in the ocean, you will see it's moving up and down because water waves are transverse waves. So in this case, you are supposed to define what we mean by a transverse wave. A transverse wave is a wave where particles vibrate perpendicular to the wave direction. Examples of another transverse wave, we can talk of light waves. Yeah? If a spring is moved up and down like this, it will create transverse wave. If a rope is jacked up and down like this, it's going to create transverse waves. If you want to determine the wavelength of a water wave, you are going to measure the distance between the wave fronts. So we are having wave fronts here. So if you want to find the wavelength, you're going to measure this distance. And when I measure this using my ruler, I got it around 0.9 centimeters. But in the equation, we were told that 1 centimeter on the diagram represents 2 centimeters in the lab. So meaning we can say 1 is equal to 2 centimeters. So because I measure the diagram, I'll say 0.9 centimeters is equals to what? So if we work it out, you will get a value which is approximately a value that is approximately 1.8 centimeters. So that we can be able to use that wavelength to work out the wave speed since we were given frequency. Because if you have the wave equation v is equals to f lambda, frequency times wavelength, then we can be able to go ahead and use the wavelength in meters that I have gotten in the previous section, so that I can be able to work out what speed was this wave. That was going to be 0.27 meters. Now we have the concept of Doppler effect that is being brought in context here. Remember, Doppler effect is the relative change in frequency of a wave due to relative motion between the source and the observer. So since the source is moving forward, you will find that the wave fronts will be closely packed together. The wave front will be very, very close. Yes, the source is moving forward, the wave fronts will be very close. And where the wave fronts are very close, it means the wavelength is going to be shorter or smaller. Now remember, since the wave speed has not changed and the wavelength has become smaller, then we are going to say frequency in this region here is going to be higher than the lower region at that given point. So the question was asking us to explain how the frequency of waves arriving at X compares with the frequency at which the diaper was moving up and down. Remember, the diaper was moving, we call the dipper, right? So the dipper was moving up and down. So as the dipper is moving up and down, it was creating water waves. Huh? So just assume that we're having some water here and the dipper is hitting that water up and down. It will be creating wave fronts. Now since the dipper is moving up and down, as it's proceeding forward, the wave fronts towards the front are going to be what? Are going to be compressed. So when they are compressed, it means the wavelength is smaller, but the speed of the wave remains the same. Then for speed to remain the same while wavelength is going down, then frequency has to increase. So that's why I gave this particular explanation here, and I say that frequency arriving is higher than frequency at point X. The frequency is arriving at X is higher because the wavefronts here are very close. Wavelength is going to decrease, but speed remains the same. So meaning that since the wave equation is V is equals to F lambda, now since lambda decreases, wavelength decreases, F must increase for speed to remain the same. So that is how you are supposed to respond to this question in the event you are asked. Question 9 for radioactivity. We are having a counter here. And remember, we have different types of counters which can be able to read the radiations from a radioactive substance. And we're going to say this is going to be maybe a GM tube or a Geiger-Müller tube. Give the name of the suitable radiation detector, Geiger-Müller tube. Give safety precautions. When you are using radiation, remember they are harmful. They can cause cancer. they can be able to cause ionization of blood, then it means that when you are using or performing experiments with radiations or radioactive substances, ensure that you keep a safe distance from them. Ensure you are minimizing time of exposure so that you don't get exposed to this radiation for a long period of time. Hence, you'll be using taking a lot of dose into your body. Also, you can be able to put on protective clothes so that you can be able to shield yourself against those radiation. Let's talk about half-life, and remember, half-life is the time taken for the activity of a radioactive substance to decrease by half. And here we are told the half-life is 70 seconds, and the initial count rate was 840. We are supposed to calculate the expected count rate after 140 seconds. So what is going to be the expected count rate? First, we need to understand how many half-lives are in 140. Since half-life is 70, so 140 divided by 70 will give us two half-lives. So meaning that this radioactive substance is going to decay twice. So the first decay it will have, so it becomes 240, and a half of this will become 210. So the remaining, the count rate after that particular period is 210. Lastly, for part 2 of this particular tutorial, we're going to say the activity of the isotope. The activity of an isotope is the total amount of radiation emitted each second, but it's estimated that only 5% is detected. Remember, radiations are always emitted in all directions, randomly in all directions, and the detector is always in front of the radiation. So there are some radiations which are not detected. So in that process, only some percentage is detected. Now for this case, only 5% is detected. So if the count rate that was registered was 840, you are asked what was the activity of the radioactive substance. Then in that case, you'll say 840 is equal to 5%. What about 100%? And if you work it out, you are going to get your answer being 16,800 as the value at that given point. If you are interested to watch part 3 of this particular tutorial, just check in the description so that you can be able to access part 3. There's a link that is going to take you straight to part 3 and part 1 of this tutorial. See you in the next tutorial.